Hello friends, welcome to my lecture on testing of hypothesis. This is third and final lecture on testing of hypothesis. Suppose that we are given two populations. For each sample of size n1 drawn from the first population, let us compute a statistic S1 whose mean and standard deviation we denote by mu S1 and sigma S1 respectively. Similarly, for each sample of size n2 drawn from the second population, let us compute a statistic S2. This yields a sampling distribution for the statistic S2 whose mean and standard deviation we denote by mu S2 and sigma S2. From all possible combinations of these samples from the two populations, we can obtain a distribution of these differences S1 minus S2, which is called the sampling distribution of differences of statistic. The mean and standard deviation of this sampling distribution denoted by mu S1 minus S2 and sigma S1 minus S2 are given by mu S1 minus S2 equal to mu S1 minus mu S2 and sigma S1 minus S2 equal to square root of sigma S1 square plus sigma S2 square, provided that the sample chosen do not in any way depend on each other, that is the samples are independent. If S1 and S2 are the sample means from the two populations which we denote by x1 bar and x2 bar, then the sampling distribution of the differences of means is given for infinite populations with mean and standard deviation mu 1 sigma 1 and mu 2 sigma 2 respectively by mu x1 bar minus x2 bar equal to mu x1 bar minus mu x2 bar, which is equal to mu 1 minus mu 2 sigma x1 bar minus x2 bar equal to square root sigma x1 bar square plus sigma x2 bar square equal to square root of sigma 1 square by n1 plus sigma 2 square by n2. Mu x bar is equal to mu and sigma x bar is equal to sigma by root n, as we know already. For the infinite population, sigma x bar is given by sigma by root n. The result also holds for finite populations if sampling is with replacement, because when there is sampling with replacement, we can theoretically consider it as an infinite population, because any number of samples can be drawn from the population without exhausting it. Similarly, some results can be obtained for finite populations in which sampling is without replacement. In that case, mu x bar is again mu and sigma x bar is sigma over root n into square root np minus n over np minus 1. Now, these formulas mu x1 bar minus x2 bar equal to mu x1 bar minus mu x2 bar, this follows from mu s1 minus s2 equal to mu s1 minus mu s2. Okay. So, S1 bar is S1 is x1 bar, S2 is x2 bar. So, we have mu x1 bar minus x2 bar equal to mu x1 bar minus mu x2 bar and sigma x1 bar minus x2 bar equal to square root x sigma x1 bar square plus sigma x2 bar square. Okay. And we know that sigma x1 bar square is sigma 1 square by n1 in the case of infinite population. In the case of finite population, sigma x1 bar square will be equal to sigma 1 square by n into np minus minus n divided by np minus 1. Sample size is n1, so we will have np minus n1 divided by np minus 1. So, in the case of finite population of size, if we are drawing samples of size n1, then sigma x1 bar will be equal to sigma 1 by root n1 into square root np minus n1 divided by np minus 1. Okay. Now, so let us now consider testing of hypothesis concerning two means. We have earlier done the case of testing of hypothesis for a single population. Now, we will consider testing of hypothesis when there are two populations. So, to test the hypothesis for differences of means. Okay. So, we are considering the test static to be mean of the population. So, to test the hypothesis for difference of means, consider the null hypothesis mu 1 minus mu 2 equal to delta, okay, where delta is some given constant. So, when delta is equal to 0, there is no difference between the means the two populations have the same means. If delta is not equal to 0, the means of the two populations are different. In these cases, the test static, that is the mean, will depend on the difference between the sample means x 1 bar minus x 2 bar, and it is given by z equal to x 1 bar minus x 2 bar minus delta divided by sigma x 1 bar minus x 2 bar. Here we are assuming that both the samples are drawn from normal populations with known variances, and here z follows a standard normal distribution. Now, if the two populations are infinite, then the variance of the sampling distribution of the difference between the sample means sigma x 1 bar minus x 2 bar square, as we have seen already, sigma x 1 bar minus x 2 bar square. Okay? Sigma square x 1 bar minus x 2 bar is equal to sigma square 1 square by n 1 plus sigma 2 square by n 2. Substituting, we have the statistic for test concerning difference between two means as z equal to x 1 bar minus x 2 bar minus delta divided by square root sigma 1 square by n 1 plus sigma 2 square by n 2. Now, when the two variances sigma 1 square and sigma 2 square are unknown, they can be replaced by sample variances. So, if we do not know the variances sigma 1 square and sigma 2 square for the two populations, then they can be replaced by the sample variances. So, sigma s 1 square and s 2 square, provided both the samples are large, that is n 1 n 2 must be greater than or equal to 30. In this case, test static will be z equal to x 1 bar minus x 2 bar minus delta divided by square root s 1 square by n 1 plus s 2 square by n 2. Now, let us see the critical regions for testing mu 1 minus mu 2 equal to delta are. If alternative hypothesis is mu 1 minus mu 2 is not equal to delta, then we have two-tailed test. Okay? TTT we have to apply, that is, we will reject the H naught if z is less than minus z alpha by 2, z alpha by 2 and z minus z alpha by 2, that give us the critical values of z. Okay? So, let us say this is our standard normal curve. So, this is say minus z alpha by 2 and this is plus z alpha by 2. So, this is our critical region. Okay. So, in this case when mu 1 minus mu 2 is not equal to delta, okay, we know that we have to apply two-tailed test. So, this is the region which is known as the critical region. Okay. So, if z is less than minus z alpha by 2 or z is greater than z alpha by 2, then we have to reject H naught. Okay. So, that means this region is the significant region. Okay. Results are significant here. Okay. And this is the region of acceptance of H naught. Okay. This region where when z lies between minus z alpha by 2 and z alpha by 2. Okay. This is in this region H naught is accepted. If minus z alpha by 2 is less than z alpha by 2. Now, mu 1 minus mu 2 is greater than delta. If mu 1 minus mu 2 is greater than delta, then we know that we have to apply one tailed test, ROTT. Okay. So, in this case what happens, if you look at the standard normal curve, the area under when z is greater, this is your critical point z alpha. So, when z is greater than z alpha. Okay. When z is greater than z alpha, then we reject H naught. So, this is the region which is the critical region. Okay. So, reject H naught if z is greater than z alpha, and when mu 1 minus mu 2 is less than delta, we apply LOTT. Okay. In the case of LOTT, we have let us say this is minus z alpha. Okay. The critical value here. So, in this case, so this is the region of a critical region here. Okay, CR. So, when z is less than minus z alpha, when z is less than minus z alpha, we will reject the null hypothesis H naught. If z is greater than minus z alpha, then we will accept the null hypothesis and we will say that the results are not significant. If z is less than minus z alpha, then we say that the result is significant. Okay, and we have to accept the alternate hypothesis. So, the cases 2 and 3, okay, this case and this case, okay, are used to determine whether one product or population is better than or superior to the other product. Now, let us consider this problem. An examination was given to two classes consisting of 40 and 50 students respectively. In the first class, the mean mark was 74. So, x1 bar here, x1 bar is equal to 74. Okay. Standard deviation S1, we are given the sample standard deviation. So, S1 equal to 8 and then x2 bar, okay, x2 bar is equal to mean mark is 78 for the second class, and S2 is equal to 7. We have N1 equal to first class has 40 students, so N1 equal to 40 and N2 equal to 50. Okay. Now, we are to decide, is there a significant difference between the performance of the two classes at a level of significance 0.05, 0.01. So, let us first consider the case A. Here alpha is equal to 0.05. Okay. Now, let us so our null hypothesis is that there is no significant difference between the performance of the two classes, that is the difference whatever it is just due to a chance. Okay. So, H1 H0 is mu1 minus mu2 equal to 0. Okay. Delta is equal to 0. We are assuming that the null hypothesis is that there is no significant difference between the two classes. Okay. While alternative hypothesis is that mu1 minus mu2 is not equal to 0, that is there is significant difference between the two classes. Okay. Now, when alpha is equal to now, so here mu1 minus mu2 is not equal to 0, it means that we have to apply two-tailed test. Okay. We have to apply two-tailed test, and let us see for alpha equal to 0.05 what are the critical values of Z. They are given in a table at the end of this lecture. So, let us see. Okay. So, 0.05. Okay. 0.05 for the two-tailed test, the critical values are minus 1.96 and 1.96. Okay. So, let us go there. So, critical values of Z are minus 1.96 and 1.96. Okay. So, this is Z alpha by 2 minus Z alpha by 2, this is plus Z alpha by 2. Okay. So, if Z lies between minus 1.96 to 1.96, okay, then H0 is accepted, otherwise it is rejected. Okay. So, let us find the value of Z. Z equal to x1 bar minus x2 bar minus delta divided by square root of S1 square by N1 plus S2 square by N2. X1 bar minus X2 bar, X1 bar is equal to 74, okay, 74 minus X2 bar is 78, delta is equal to 0 divided by square root of now S1 square is 8 square means 64. 64 divided by N1 is equal to 40, and then plus N2 S2 is equal to 7. So, 7 square, S2 square is 7 square means 49 divided by N2, that is 50. Okay. Now, let us calculate this value. So, Z is equal to 74 minus 78, that is minus 4 divided by square root. Here the LCM is 200. Okay. So, 200 and then we have here 320 plus 196. Okay. So, this is minus 4 divided by square root, this one is 516. Okay. 516 divided by 200. Okay. 516 divided by 200, and this is then equal to minus 4 upon square root of when you divide by 200, this is 258. Okay. So, 2.58. Okay. So, minus 4 upon square root of 2.58 comes out to be minus 2.49. Okay. So, this is minus 2.49. 2.49, and actually this square root of 2.58, okay, which gives us the value of this sigma x1 bar minus x2 bar. This is equal to 1.606. So, square root of 2.58, actually this is the value of sigma x1 bar minus x2 bar, sigma x1 bar minus x2 bar. This is equal to square root s1 square by n1 plus s2 square by n2. This is equal to 2.58, which is 1.606. So, this value 1.606 is the value of this denominator. Okay. So, this is minus 4 upon 1.606, which comes out to be minus 2.49. Okay. Now, this value of z, let us see whether it lies between minus 1.96 and plus 1.96. No, because if you draw this curve, okay, this is minus 1.96 to 1.96, okay, and z is minus 2.49. So, minus 2.49 is here. Okay. So, minus 2.49 is less than minus 1.96. Okay. Therefore, this is the region, this is the critical region. Okay. This critical region. So, H naught is to be rejected. Okay. H naught is rejected, which means that mu alternative hypothesis is accepted, that is there is significant difference between the two classes. Okay. So, we have the result, we can conclude that there is significant difference between the two classes at 0.05 level of significance. Okay. Now, let us look at 0.01. What happens if you take alpha equal to 0.01? Okay. So, when alpha is equal to 0.01, let us see the values of z. Okay. The critical values of z. So, when 0.01, critical values of z are minus 2.58 and plus 2.58. So, here minus z alpha by 2 is minus 2.58 and z alpha by 2 is 2.58. Okay. So, here the value of z which we have calculated is minus 2.49. So, since minus 2.49 is greater than minus 2.58, okay, H naught is accepted. Okay. So, H naught is accepted, which means that at 0.01 level of significance, okay, we can say that there is no difference between the two classes. Okay. So, there is no significant difference between the two classes at alpha equal to 0.01. Okay. That means, both the classes performance is the same. Okay. The whatever is the difference, it is just due to a chance. Now, let us go to example 2. Okay. The mean mass of 50 male students who showed above average participation in college athletics was 68.2. Okay. So, here x1 bar is equal to 68.2 and n1 is equal to 50. With the standard deviation 2.5 kilograms. So, S1 is equal to 2.5, while 50 male students who showed no interest. So, N2 equal to 50, okay, N2 while 50 male students who showed no interest in such participation has a mean mass of 67.5. Okay. So, X2 bar is equal to 67.5 with a standard deviation sigma S2 equal to 2.8 kilogram. Test the hypothesis that male students who participate in college athletics are more massive than other male students. So, let us say our H naught is the null hypothesis is the mu 1 minus mu 2 is equal to delta equal to 0. Okay. That is they are the male students who participate in college athletics are the same as the other male students, okay, on average. So, alternative hypothesis is mu 1 minus mu 2 is greater than delta. Okay. That is mu 1 minus mu 2 is greater than 0, okay, delta is 0. Okay. So, that is our other hypothesis, that is the male students who participate in college athletics, okay, are more massive than other male students. Now, we are to consider alpha equal to 0, we are alpha is not given to us here, okay, at what level of significance we have to test the hypothesis. So, on our own let us consider alpha equal to 0.05. So, let us see when alpha equal to 0.05, since mu 1 minus mu 2 is greater than delta, we have to apply ROTT, right one tail test. Okay. So, in the case of ROTT, when alpha is 0.05, let us see what is the value of Z. So, at 0.05 the value of Z is 1.645, minus 1.645 or 1.645. Okay. So, the critical values of Z are Z alpha equal to minus 1.645 or 1.645. So, let us find the value of Z. Z equal to x1 bar minus x2 bar minus delta divided by sigma x1 bar minus x2 bar. Okay. And we know that sigma x1 bar minus x2 bar is equal to square root S1 square by N1 plus S2 square by N2. Okay. This is equal to square root S1 square, S1 square is 2.5 square divided by 50 plus 2.8 square divided by 50. Okay. So, if you calculate this value, it comes out to be 0.53. Okay, 0.53. Now, this is equal to x1 bar is 68.2 minus 67.5 divided by 0.53. Okay. Delta is equal to 0. So, this is equal to 0.7 divided by 0.53. Okay. It comes out to be 1.32. It comes out to be 1.32. Okay. Now, let us see if Z lies between okay, we have to apply right ROTT. Okay. So, if Z is greater than 1.645, okay, if Z is greater than 1.645, then H naught is rejected, otherwise H naught is accepted. So, here Z is equal to 1.32, since Z equal to 1.32 is less than Z alpha equal to 1.645. Okay. Here you see this is your critical region. See, this is your Z alpha equal to 1.645. This is critical region. Okay. So, and this is your region of acceptance of H naught. Okay. So, Z is equal to 1.32. So, 1.32 lies here. Okay. 1.32. So, 1.32 is less than Z alpha, therefore, H naught is accepted. H naught is accepted means there is no significant difference between the two classes of students, those who participate in college athletics and those who have no interest in college athletics. So, there is no significant difference between the two. Okay. Now, let us take alpha equal to 0.10. So, when alpha is equal to 0.10, the values of z are, let us see, we have to find the value of z from here. Okay. The values of z are minus 1.28 and 1.28. Okay. So, at alpha equal to 0.10, okay, 0.10, the critical values of z are minus 1.28 and 1.28. Okay. Since we are applying ROTT, okay, we are applying ROTT here, okay, and 1.32 is greater than 1.28. This is your 1.28. Okay. So, and 1.32 is here. So, we are in the critical region. So, since 1.32 is greater than 1.28, H naught is rejected. Okay. Which means that at the level of significance z equal to 0.10, okay, there is significant difference, that is the male students who participate in college athletics are more massive than other male students. So, we accept the alternative hypothesis mu1 minus mu2 greater than 0, that is the male students who participate in college athletics are more massive than other male students. So, H naught is rejected means AH is accepted, alternative hypothesis is accepted at alpha equal to 0.10. Now, let us do the problem number 3. In a random sample of 100 tube lights produced by company A, the mean lifetime of tube light is 1190 hours with a standard deviation of 90 hours. So, we have here x1 bar equal to 1190, n1 equal to 100, a standard deviation S1 equal to 90 hours. Then we have another random sample of 75 tube lights from company B, where the mean lifetime is 1230 hours. So, x2 bar is equal to 1230 and 2 equal to 75, S2 is equal to 120 hours, the standard deviation is 120 hours. So, let us now we have to decide is there a difference between the mean lifetimes of the two brands of tube lights at a significance level of 0.05 and 0.01. So, let us assume H naught, the null hypothesis, to be mu1 minus mu2 equal to delta equal to 0, that is there is no significant difference. Alternative hypothesis H1 is mu1 minus mu2 not equal to 0, that is there is significant difference between the two samples. Okay. So, let us now find the value of alpha is equal to 0.05. So, let us find the critical values of Z are. Now, we are to apply two-tail test. Okay. So, in the case of two-tail test, the values of Z are minus 1.96 and 1.96. So, we have to apply two-tail test. The critical values are minus 1.96 and 1.96. If Z lies between minus 1.96 and plus 1.96, then we accept H naught, otherwise we reject H naught. So, let us find the value of Z. Z equal to x1 bar minus x2 bar minus delta divided by square root S1 square over N1 plus S2 square over N2. This is nothing but sigma x1 bar minus x2 bar. Okay. So, x1 bar minus x2 bar is 1190 minus 1230. Delta is equal to 0 divided by square root S1 square. S1 square is 90 square divided by N1 is equal to 100 plus S2 is 120. So, 120 square divided by N2, that is 75. Okay. Now, let us find these value here. So, 1190 minus 1230 is minus 40 divided by square root 90 square divided by 100 plus 120 square divided by 75. Okay. Now, let us see sigma x1 bar minus x2 bar, okay, which is the denominator in the value of z. It is 16.5227 and z comes out to be minus 2.421. Okay. So, this sigma x1 bar minus x2 bar, okay, sigma x1 bar minus x2 bar, okay, that is under root 90 square divided by 100 plus 120 square divided by 75. If you calculate this, it comes out to be 16.5227. Okay. And when we put the value here, we get minus 40 divided by 16.5227, and this comes out to be minus 2.421. So, minus 2.421. Okay. Now, let us see, we have z lies between minus 1.96, the critical values are minus 1.96 and plus 1.96. Okay. So, this is critical region in the case of two-tailed test. Okay. We are getting z equal to minus 2.421. So, since minus 2.421 is less than minus 1.96. Okay. Okay. Therefore, we are in the critical region, this critical region, this and this critical region. Okay. So, we are in the critical region. So, we have the result that H naught is rejected, H naught is rejected here, which means that there is significant difference between the two populations, okay, between the tube-lights manufactured by company A and tube-lights manufactured by company B. Now, when you take alpha equal to 0.01, let us see what happens. Okay. So, alpha equal to 0.0, let us now take, and now let alpha be equal to 0.01. Then for RTT, let us see what are the critical values of Z. So, the critical values of Z are minus 2.58 and plus 2.58. So, the critical values are minus 2.58 and plus 2.58. Okay. Now, the value of Z is minus 2.421. So, since minus 2.421 is greater than minus 2.58, okay, H naught is accepted, which means that there is no significant difference between the tube lights manufactured by company A and the tube lights manufactured by company B at alpha equal to 0.01. Okay. So, we are accepting H naught. Now, let us go to last question. Test at 0.05 level of significance, and manufacturer claim that the mean tensile strength of a thread A exceeds the mean tensile strength of thread B by at least 12 kgs. Okay. So, our null hypothesis here is that mu 1 minus mu 2 is greater than or equal to 12. Okay. The mean tensile strength of thread A, that is mu 1, and mean tensile strength of thread B, that is mu 2. Okay. So, mu 1 minus mu 2 is greater than or equal to 12, and then alternative hypothesis H 1 is mu 1 minus mu 2 is less than 12. Okay. Now, if 50 pieces of each type of thread are tested, so N 1 equal to N 2 equal to 50. Okay, are tested under similar conditions yielding the following data. So, for type A sample size is 50, for type B also sample size is 50, mean tensile strength for type A x 1 bar is equal to 86.7, okay, and mean this x 2 bar which is equal to 77.8, okay, and S 1 is equal to 6.28, S 2 equal to 5.61. Okay. So, Z is equal to x 1 bar minus x 2 bar minus delta is 12, okay, divided by sigma x 1 bar minus x 2 bar, okay. This is equal to x 1 bar minus x 2 bar. So, 86.7 minus 77.8 minus 12 divided by under root S 1 square. S 1 square means 6.28 whole square divided by 50 plus 5.61 square divided by 50. This comes out to be equal to minus 2.60. Okay. Now, this is minus 2.60. We are to test it at 0.05 level of significance. Okay. Now, here we are mu 1, we are having mu 1 minus mu 2 greater than or equal to 12, we are testing mu 1 minus mu 2 less than 12. So, this means that we have to apply LOTT. Okay, we have to apply LOTT. So, left one tail test we have to apply. So, when we have 0.05 at 0.05 level of significance, let us see, we have critical value of Z for one tail test as minus 1.645, okay, and 1.645. So, let us see whether the value of Z that we have got is less than minus 1.645. Okay. So, critical values are minus 1.645 or plus 1.645. Okay. Now, minus 2.60 is less than minus 1.645. Okay. So, this means that we have to reject H naught. Okay. This is your critical region. Okay. This is minus 1.645. So, we are in the critical region. Okay. So, H naught is rejected, which means that mu 1 minus mu 2 is less than 12. That means, this manufacturer claim is not tenable. Okay. So, manufacturer's claim is not right. Manufacturer's claim at 0 alpha equal to 0.05 is not tenable. Okay. Because we have to reject H naught and we are accepting that mu 1 minus mu 2 is less than 12. Okay. So, with that I would like to end this lecture. Thank you very much for your attention.